In today's videos we are talking about Knobi. Knobi is a microcontroller and a multi-tool able to mix, attenuate, invert, display and multiply any kind of signal. Yes, that's basically what it is. The idea started like I wanted to have a knob. When you turn it, it will control your whole system, you know, that kind of idea, so a microcontroller. But at the end, I got in the way during the years of developing this multi-tool that is not just a microcontroller at the end, because you have, here you can see A, B, C, and D. Those are the four inputs that are mixed together. So you can plug one of them, two of them, three of them, or all four of them, and this acts. This first block acts as a mixer, as a CV mixer or audio. You can mix whatever you want there. Then you have this R. R stands for reference, and this is an output, and outputs are kind of a really precise 5-volt voltage reference, and you can plug it, for example, in the first input, and there you have 5 volts. And as you can see below, there is a meter. This voltage meter reads the voltage that you fed in, but it reads that after the attenuation, so after the attenuation pot and the attenuverter pot, because that's what we have here. We have another switch. This switch controls the offset of this knob, and it goes here goes from the 0 to 10 volts, and in the center we have 0 to 5 volt, and the other one goes from 5 to -5. And you can see the meter only reads positive voltage, so if you want to read negative voltages, we have to turn the attenuverter, as you can see, -5 volt. The meter itself has a precision of 0.2 volt, so it just acts as a reference. So to have an actual idea of what's going on there, or what's the range of the CV that you are feeding in, and it only reads voltages when it's below a certain range, so it's not gonna read audio voltages, because they are really those waves are really fast. So it only reads voltages when it's below a certain range and of hertz, so speed of that wave. So then the signal passes through this attenuation pot, then goes into an attenuverter, and the outputs, as you can see, are numbered 1, 2, 3, and 4, and that symbol before them stands for multiplication, because if you have, for example, if you want to multiply a signal by 2, you just have to take this output there, or if you want to multiply a signal by 4, you can have this output, the last one. And this chain can be broken in any point, so you can have you can use Knobi as a standard multiple if you want. So plug a signal here, leave the attenuation at maximum, attenuverter at maximum, and just use the 4 output to have a multiplication per one, like of your signal. This is a tactile switch, and it will fire, let's take out the reference, it will fire a 5 volts to all of your 4 outputs. Of course, you can break the normalization, and from the double 2, it will output 10 volts, since we are using that factor of multiplication. Or we can have 4 jacks plugged in and have just 5 gates going, whatever you want in your case. As you can see, it's kind of, you can configure Knobi to be used in any situation when you are dealing with CV or audio and you want to mix, attenuate, invert, or multiply a signal, and even use it just as a reference, or to send manual gates to your drum modules, or all this function all together. So that's it. It's basically an army knife that I One is never enough in my systems usually, and here I have 3 of them, but I have other cases when I just play I can play a whole set just turning this 5 of these knobs all together and changing the modulations of a whole composition just with this macro. So in that sense it becomes a proper macro. Maybe I have because the idea Knobi came from a module that I built with just a few resistors to test out a feature of Tabor that someone asked me if Tabor was capable of doing this specific thing, and I built that module, and the idea of Knobi came from that idea. So I think that it's the best the best would be to actually test it with Tabor and as a macro source. This Knobi is set up so that the inputs is its own reference, and then in the offset of 0, 10, and the 4 outputs so are not multiplied but are just sent through Tabor RM input that controls the starving of the oscillators. 2 other outputs are going into the frequency and the resonance control of Goblet, and you have the last one is controlling the mix of the reverb, so the amount of reverb in the final composition. So I'm turning on the volume, turning up the volume. Actually, Knobi is the perfect companion for Tabor because precisely control the RM input is one of the key, is one of the secrets to tame it and to make it even more versatile. Now, let's see what's happening if we add an LFO into one of the inputs of Knobi. Triangle one from GitCat. Let's play with the range of the offset. Let's add another Tabor, because why not? So now we're actually mixing audio and CV together. Another LFO. As you can see now the meter is stuck because changes are happening too fast. And this is an example of how Knobi can be used as a microcontroller, as a mixer, and as a manual gate tool. You can see there's a ton of feature, and I'm just curious about how are you gonna use it, if you are gonna use it, and if you need it. And please tell me how, and if you have any idea of any request for another video, whatever, please let me know. And I know that this camera is never in focus, never, it's impossible now. Okay, and this was Knobi. Thank you for watching, and see you in the next video. It's gonna be about Ascolta.